Right, so here's the volume scale factor, and just like area scale factor, yes, square that. Volume scale factor, you find the linear scale factor and cube it. That's it. Okay, so we'll just do this quickly. So what we've got two similar objects. One we know everything about, one we don't. So if we know everything about it, going to call that the old one. If we've still to work out some information about it, call that the new one. So I'll just do two at a time, right? So that's going to be, it's got everything that we need, so that's old. Still to find something out about it, so that's new. So what we've got, remember, is your linear scale factor is equal to new divide by old. So what we've got is the linear scale factor for these bottles. Okay, that's in new, so that's, and it's going to be bigger than 1 because the bottle's a bigger one, so that's going to be 30 over 20, and that is going to be 3 over 2. Okay, this one is reduced in size, so it's still new over old though, so that is going to be, the linear scale factor is going to be 9 over 12. Okay, which is, sorry, that's 3 over 4. Okay, so that's 3/4. So if you just think about shapes increasing, so that's why it's bigger than 1. Shapes decreasing, so that's why it's less than 1. Now the volume scale factor, I should say, it's actually just equal to the linear scale factor cubed. Okay, so what we've got here is a volume scale factor equals 3 over 2 cubed. Okay, and the volume scale factor for this one equals 3 over 4 cubed. Now to actually work out what a milliliters is, we're going to just say a milliliter equals your volume scale factor times the shape that we do know the value for, so that's 560 milliliters. This one is, this is what happens when you rush it, is C is going to equal volume scale factor times 256. Okay, so that is 3 over 2 cubed times 560, and that is 3 over 4 cubed times 256. So let's see if I can put this in a calculator, or it all goes pear-shaped. So let's have a wee look here. Right, so I'm just going to say 3 divided by 2, we're going to cube it. Okay, and then we're going to times that by 560. And that gives me a volume of 11890 milliliters. Okay, if we then look at the next one, let's clear the memory, it's 3 divided by 4. Okay, and we're going to cube that. And then we're going to times that by 256. And that is 108 grams. So, linear scale factor bigger than 1 because the size of the similar objects increasing. Linear scale factor smaller than 1 because it's decreasing. Volume scale factor is just the linear scale factor cubed. Okay, so that's the exact same in both instances. And then you times the volume scale factor with the volume you do know of. Do that for both. Just double check. I mean, the smaller one to 560, the bigger 1890, so it's a larger number. Obviously, just want to double check all your workings. And it's reduced in size, so it should have less grams in it. Okay, so hopefully that's helpful.